Welcome in the third day of our conference. We have today another three great talks, so I will be not prolonging introduction much more. I just only wanted to thank again our diamond sponsor, Allegro Pay and Demand, for helping us this conference to happen. And I'm super interested in today's talk. We are starting with Rafał that will talk about leaky.net, so we will see what he has to say. Hello, Rafał.
Hello, hello.
And the scene is yours. I will not, take your time. So good luck, and I'm hiding myself.
So thank you very much. Once again, hello everyone. Hope you enjoyed the conference so far. Really happy that you decided to join this session. Today we'll go through different stories about leaky.net and how we lie in our code bases. But before we start, let me quickly introduce myself. My name is Rafał Schmidt. I'm a software engineer with hands-on experience in creating web applications and server-side services with a broad knowledge in a Microsoft stack, including Azure Cloud, and I work at Allegro Pay, where I be one of the fastest growing fintech in Poland. But beyond that, I currently focus on the insurance industry actually, because we are building a brand new product called Allegro Care. And as I said, it is a great pleasure to speak in front of you today, even though it's online. So let's get into it. So I believe most of you seen one of those. This example, this exception, and that one, and maybe some of you seen the one with panic and other with a pointer in name, and probably a few more of them. And I wonder how many of you recognize all of them, but some folks at this time resonate with the guy on the right, and other, including me, feel more of the left one. And we can all agree that something is wrong. And if you still don't know what I'm talking about, in case you haven't seen this one, and maybe you're just the one guy who asked this question on Stack Overflow. So what is a null pointer exception and how do we fix it? This one sounds a little funny to me at first, because how it's even possible? Maybe he's just a lucky guy. I don't know. It's quite hard to explain, at least for me at that moment. But this question was asked 13 years ago, and I believe I was in an elementary school at this time, and the only null I remember from that time was that one. And however, after seeing this, the first I got cold sweat, and the only question that pops in my head was, what about my world? Is it gone? And then I googled the corresponding forum and wrote something like this. Hello, yesterday I was playing Minecraft on different servers and everything was fine. And today when I try to get to any of those, I get an error, and obviously with a screenshot and please help and a few more exclamation mark just in case. So to add the seriousness to the situation, a few more. And case 2. So what programming languages prevent null pointer exceptions? And another answer we've seen, and what I see is PHP. Technically, it doesn't give a null pointer exception. Exception is just a warning. And you might think, those are the happy people, the language that just respect them. And on the other hand, there is a madman, and check out this question from the official PHP issue tracker, and it starts with I desire a null pointer to be thrown, like in Java. And fortunately, this one is one of those happy stories with a happy ending, because the status was one fix. And even though it could be beneficial for the language, it's completely against the fundamental assumptions of it, because the PHP doesn't have pointers and do not throw exceptions from its core. So maybe it's not the best idea to make fun of those other languages, but that's what this presentation is about. It's about those type of decisions in different languages and consequences about them. So would be good to end up here with a conclusion. So I found one which is extremely simple yet very wise. So ask on Quora, which programming languages handles null pointer exceptions the best? And the answer, which I couldn't agree more, is languages that don't allow null values. And I understand at this moment you might feel at first, yeah, that's right, that speaks to me, and then it goes more of into, damn, we cannot change much. That's a silly conclusion. And you might think that these types of errors, it's normal. It's our bread and butter. And maybe for some, it probably is, but I cannot agree. And let me ask a simple question here. How would you react to it if you would see this one? The engineers most often goes from the observation to the comments and something like, I must admit, it's kind of unexpected, or it shouldn't happen here. That's strange. And another question which arises is, who the heck invented this lovely feature? And it turns out that was Tony Hoare, is the man who invented the Null reference. And in 2009 at the conference, he stated that the null he was invented in 1965 is described by him by the billion-dollar mistake. And he also said that my goal was to ensure that all references should be absolutely safe, which with checking performed automatically by the compiler, but it didn't really happen. He said but I couldn't resist the temptation to put it a null reference, simply because it was too easy to implement. And it turns out that it's a bit like back then. We now, more than 50 years ago, make different mistakes and get the same null exceptions. And decision that was made way a long time ago has an impact on us to this day. So are there any solutions? I beg these questions. And absolutely, in Kotlin, we have a distinguished system with that references can be hold null or not nullable types, and it's called the nullable types. And regular initialize is treated as a non-nullable by design. And in addition to it, if you want to allow null, you declare a variable by adding a question mark at the end of it, and that's it. So let's move on to F#. In F#, there is a slightly different concept. There is an option type, which has a choice of two cases. One is a sum, and another is a none. And if you go to the definition, we have a generic with a choice. There is a sum of a generic and none with nothing, basically. And Java is here more like a JavaScript when it comes to NRT. It can be solved by a million ways. One is optional and also throw. Another is the JetBrains annotations with non-nullable. We have other annotations, for instance, findbacks, obviously very popular Lombok, and another one, and another one. And coming back to C#, the solution is basically a copy of Kotlin. All nullable objects must be declared with a question mark postfix, otherwise those are non-nullable. And no surprises, really. So once again, what about nullable reference types? How can we still get nulls in 2022 if we have all of those features in different languages? Because in Microsoft, it's just a compile time warning. That's a sad truth. And what's the issue? Why does the problem occur at all? So let me explain. We need an example. So I've generated two APIs in ASP.NET Core and compared them. First one is a project that is very standard, well-known. It's just the raw weather forecast example prepared by the Microsoft itself. And what's the difference between the .NET 5 version and .NET 6 version is if we skip the sugar here, which is the implicit global usings, we will notice that the nullable in .NET 6 is enabled by default. It's true, but we can always turn it up if you want. And going further, there is a subtle difference between those two. However, it shows something which shocked me at first. We have a summary here, and those are two versions of a summary in .NET 5 and the .NET 6 version. And this spot is the most exciting one because the weather forecast The DTO which we have here is used exactly once in a one place, yet there is a question mark saying that it's optional. And why is that? You might wonder why they just didn't do a non-nullable summary, which means that we will basically remove the question mark from here. And it's because they will be liars, because the non-nullable property summary is uninitialized, considered declaring the property as nullable. And I know that's brutal, but this is how it is. When I've seen it the first time, it was more of a like this man. Why is it compiling at all? This time, at this moment, in this solution, you can basically comment this out, so you don't fill the summary at all, and the build will still succeed. The code will compile. The implementation here creates the impression that lying in the code base is just allowed, and we can ignore this warning at all. But no one really want to be compared to the Pinocchio or obviously any other liars. So you can call me here a perfectionist, but when it comes to warnings in general, when I see it in my IDE, see this, it's weakens and masochist in me, and I'm starting to flog myself. How do I do it? I set up treating warnings as errors, basically. And we can do it differently also. It's not only about treating warning as errors, but we can also use the warnings as errors nullable, and it's pretty much the same. And what we get if we do the switch, the build will fail, and error at the compile stage instead of warnings. And that's great. And now we have a certain anti-lie blocking tool, and we can focus on how to fix it. How can we fix this error? But let's maybe start with how to not fix this one. And definitely not by suppressing nullable warnings with the last one here, which is the null forgiving operator. And actually, it is kind of an explicit way to lie in our code base, because you can add at the end then null with the exclamation mark, and that's pretty much it. And you know what's worse about this one is that you can do the string empty and fill this with empty text, and those two are actually quite fine. And at this point, I really wish we all feel the same way, that I guarantee you it's gonna blow up. So what about the IntelliSense? Maybe go one more time and see what else do we have here. And second one isn't that bad, right? So initialize properties from the constructor here. So all right, seems fine. Now we don't have this problem, kind of. But now I stop and say, it looks like Java, Java, Java. No, I have an initialize block and I'm gonna use it. Some JVM lovers would notice a very common pattern here and use a lombok, for instance. And don't get me wrong, I'm not saying that constructors are bad in general. It's the simplest and very powerful way to make our objects initialized properly. But somehow the community, at least from my perspective, has an aversion to it, and my goal is to help them without a massive refactor to constructors at most places. So it's worth also mentioning here that the record tag, as we give is also great, as it gives us the compact way to rewrite this code and have the contract here. Although, and it has advantages, it's designed specifically for the immutability, and that's not the way we want to do it most of the time. So after my third fail, I'm saying that I'm missing something. Something is wrong. And I decided to disable this stupid warning. And currently, in my humble opinion, this solution is leaky, and my irritation level goes to almost the same as a front-end developer when they find out that there are foldable phones, because that's a whole mess right now for them. And to wrap up this sad story, if you use a nullable, then you have to treat warnings as errors. Otherwise, you're just a liar. And there is a Scott Lashen who knows about it pretty well. In 2017 presentation. In his 2017 presentation, he explained F# for C# engineers and also talked about the predictability. I strongly recommend that one. And I believe we can learn a lot from Scott. So check this one. So here's one question arise. How can we help ourselves? What should we do to make our lives more enjoyable? How can we really tighten screws to make the static code analysis somehow guide us into more predictable code base and fewer bugs? And so going back to NRT once again, let's go back to basics. And how you can see from the documentation here, this is only a compile time feature. And according to the documentation, unfortunately, we can ignore the warning and move on as I saw you. And Microsoft is throwing the bug on the software engineers, saying that they should make sure that the code is not throwing exception at runtime. And for me, it's like being in a statically typed ecosystem and at the same time in the world of Python or JavaScript where the typing is completely optional. And to show you how critical it is, let me give you an example. Here's a person class. Imagine we are doing a person class with 3 fields: first name, middle name, and the last name. One of those is optional, the middle one. And when we deserialize an empty JSON to an object, we get nothing, and there will be no exceptions thrown. The object will be in a very unexpected state because the serialization does not provide the nullability check. It's not only my problem. It's not something that I've made up. The whole community is aware of it. And there are multiple threads about failing null deserialization on non-nullable reference types. So how about JVM? How does they relate to it? And it turns out that they have a proper solution. For instance, Jackson will fail to deserialize the target Kotlin type. There will be a missing Kotlin parameter exception here, and that's how we want to be. That's where we want to be. So I thought if they can, we can too. So we started our implementation. One of our engineers sat down and wrote the proof of concept of this NRT validation. And whoops, it turned out that playing with reflection for NRT, it's not a piece of cake or a late Friday task. And you know what's even worse? That we make multiple mistakes, and there were extreme rare cases, for example, with generics, and the solution became not very trivial because what's the point of building the whole tree of reflection every single time? So metaprogramming is not something what we want to do, so we decided to look for something ready. There are several libraries which solve the problem, and that's what we want, really. So for instance, the Notion reflection, which is an advanced reflection API for NRT checks, is something what we really want to have here. And there are others, for instance, the nullability info, which exposes top-level nullability information from reflection. So how to use them right now. So coming back to our example with a person, let's check the state after the serialization. Let's ensure valid nullability here. We want to fail fast and do not pass the object further anyway, in the same fashion that Kotlin did or the ISP does if we turn on the nullability. But we want to do it in different places, let's say closer to the database or other clients. And it's very simple, yet extremely powerful check, which will save us a ton of time during the debugging session. So let's take care of an initialization right now. As you remember, we had the person object, and we used to have a warning, but now we have an exception here. And as we switch to the error, we got the non-nullable property. Last name is uninitialized. But theoretically, we can still create the object of a new person here without really passing anything into it. And as you can see, there are no much errors here. So what's even worse, we can possibly say, shut up, C#, I have a null forgiving operator, and I'm ready to use it. And that's a big problem. And thankfully, Cezary Piątek created a cool tool, little repository called C# extensions, which is actually a set of analyzers which add different attributes that consist of different static analysis rules for requiring property initialization. And how we can use it? It's very simple because it's just a one-liner here. We just mark the whole assembly with it, and that's pretty much it. And what's really changed right now? Now we are getting a missing initialization of properties, first and last name, because the middle one name was optional here. And this is really what we wanted. And now also we can do this so that we remove those nulls from the end, because what's the point of having them right now? And as I said, there is nothing wrong with constructors, but we want the initializations construction to behave properly with nullables. And Cezary, wrote the whole article about this, so be sure to check this out. And since the whole community sees the problem, knows about the problem, different tools are being developed, is Microsoft actually listening? And kind of. The coming C# in .NET 7 will allow us to mark fields as required, which will provide some special analysis, which is similar to the C# extension as I showed you before, but it will be native in the language itself. But the problem is that the .NET 7 will not be LTS, so there's a huge chance that different organizations will not switch at all, and which is a bummer here. So what about migrations here? How can we implement NRT in the existing project? Let's say we are in the .NET file and we have an existing code base. We have an issue. Microsoft really didn't provide many guidelines how to tackle this issue, so there are pretty much two ways to handle it. First one is and easiest one is to go and enable it file by file. And you write some new code, you annotate it with a new reference type exclamation mark at the end, and that's pretty much it. So the new code can be already using this feature, and the old one is, let's say, a crappy one, a lying one. And that's the first approach. And the second one is to go by the business functionality. It's more demanding, and going by the business logic, business functionality, we don't have to go by the whole solution. It can be project by project, and I must say it's a quite hard one because you don't really know where's it's a safe spot to remove to mark it as a non-nullable. And obviously we could mark everything as nullable because that would be a similar approach which we have before C#8. But what's the point of using this then? So it's not that simple. You have to go through the code base, check different ifs, and maybe then you will be quite sure that your contract is not lying then. So moving on, are there any other ways to lie other than nulls? And I believe that primitive obsession is another lie which we can avoid quite easily. So imagine that you are in the insurance industry and you need to develop a service or more of a method here. So you get the method that will get the entity from the database. So nothing sophisticated. We've done it multiple times. So you write a task and get insurance by ID with two parameters, user ID and the insurance ID, let's say. And can you catch a problem with it here? Let me show you. We have a method, and here we use it. We pass two parameters here, and that's it. So the problem here is that I can literally swap those two, and it will still compile. It's funny because Rider will even add a prefix here saying that, okay, first one is a user token, but you pass the insurance ID, and second one, obviously. So the hint will be even added here to maybe tell you that something is wrong. So coming back to our example, instead of passing two primitives here, in this case, those are two strings, but could be ints, let's say, we can use strongly typed identifiers. And why would you do it? What's the point of doing this? It's because then we will get the compile time check and that cannot convert from one type to another type. And at least there should be less lying because of this, less mistakes. So take a look. We have a strongly typed method, identical to the previous one, but with different types of parameters here. And again, we pass those two parameters. And now if you will try to swap those two, you will get the error here on the insurance ID because you should pass a user token here. And that's great. This is a very simple way to enforce us to pass properly things. And this is lovely. And what's now? How can we actually create those strongly typed ID? And the effortless way is to use record types. If you need some extra performance, consider using structs, the latest and greatest record structs, but you get the idea. It's a one-liner, which can really save you a ton of time because debugging this swapping is very hard. And I believe we all went through it already. So can we make it or more exciting? Be like Apple, let's say, the best strongly typed ID we've ever made. Can we say it? Kind of. It turns out that we can, but the question is more of it that we should. And here's an example of an ID made by one of libraries. It's called the Mesautu framework. You pronounce it maybe a bit differently, but there are a bunch of those, and they do exactly the same thing. Generate a lot of magic, called boilerplates sometimes. And at most, this code can be a collage here because it's not quite something that I will show on the presentation, but you get an idea. To add it, it's trivial because you go through the documentation, and it's basically a source generator for properties, quality members, and most importantly, Json converters here. The package will be if you mark it as a strongly typed ID, the package will generate the following code. At first, a bunch of getters, parts, helpers, and different things. Useful, yeah. And for me, the most important one are Json converters, actually, because those are the good stuff, as we can pass it directly in our controllers, let's say from route as a parameter, which will simplify the construction of those. You don't need the strings in the controllers, so you have an end-to-end flow, and it became completely transparent to you. And that's pretty much it. A very simple tool to solve the swapping problem. So moving on to another example, now focus on, because I'm gonna change slides quite quickly. So imagine that there was a call. We need to implement invoices for our insurance system. So as we need invoices, we create a record for invoice. And it has obviously a simple type ID, as we learned a second ago. Obviously, it has also types, because it can be either unpaid or a paid one. And right now, it's going to get a bit tricky. Because for unpaid invoice, we have a due date, which is a date only. And for a paid one, we want to fill the paid at, which is a full time start with the actual payment time. And as you can see, those last two fields are nullable, as each of those depends on the type. And it's a common strategy. We've all seen it somewhere. I believe we've all seen it. If you do the DTOs, sometimes it's simplified to something like this. So let's initialize it right now. We generate the ID, set the type to unpaid, and we lie. And we basically lie here because it's possible to make an unpaid invoice with a paid at date. Nothing really stopped us from it, and we can basically very easily create the invalid state. And good luck if you to someone who's gonna debug it. So what about OOP, object-oriented programming? So let's take into account all OOP standards, and it's time for a small refactor here. So once again, strongly type ID, and something new happens. There's an abstract invoice class which is a marker kind of, because we have an invoice and invoice ID as a parameter here, but similarly as before, we have an invoice, unpaid invoice, and here's the inheritance. There is a derivative class which inherits from the abstract one, and same paid one with an inheritance. And let's now do the switch. And a quick disclaimer, I know this one could be done with an abstract method, let's say, but let's imagine the logic is slightly more demanding and it doesn't fit really to the object itself. We do the switch. For an unpaid one, we do the pay now. For a paid one, we say already paid. And again, it's getting miserable. Why? Because the switch expression does not handle all possible input. It's not exhaustive here. And as OOP is always open for adding new implementations, we are kind of forced to, for example, the pattern, default pattern is not covered. So even though we know there are exactly two implementation of this, we are forced to add this dummy default. And for me, it's a small lie here. So another question I would like to ask is this default actually safe? So moving on to the example. So this is a recap of the current implementation. So what if I will add another one, calling this a random invoice with a cheating field? Doesn't really matter here. So what would you expect here? Because I will expect literally nothing. Unfortunately, nothing. There's a fantastic presentation about this one, because once again, Scott on NDC Oslo created a presentation about those differences and, for instance, what's the difference between choice type and the inheritance. And in case you have more time, actually, I highly recommend this book. It's Domain Modeling Made Functional. For me, it's a masterpiece, actually. And even though you don't know the F# language, and even though you don't use it on a daily basis, you can go through it very easily. And the book is open-minding and mind-blowing in the same time. So what clicked me about in this book, after reading this book, was the approach with modeling with unions. Instead of creating classes with initialized fields or enums inside of it, or sometimes overcomplicated inheritance. So once again, a type identifier. This time it's a F# code, but believe me, you can follow this along. The syntax is pretty simple. One more time, we have an unpaid invoice, and it's called in F# a product type, but basically it's the same as record or a tuple. Once more, paid one, and here's something new. It's a top-level invoice type with two choices. And in F# it's called a choice type, sometimes called a sometime, and you can call it also from Wikipedia if you're going to read it. It will be probably a tagged union, and in F# it will be a discriminated union. It's a fancy one. And now we need a map to message function, which takes the invoice as a parameter and do the switch, the same switch we've done before in F# a second ago. This is going to be a same switch. So going back, we have a pay now case, already paid case, and if you will try to add the default pattern the same way as we've done with C# because we were forced to do it, there will be an error saying that this rule will never be matched. And how is it possible? It's because the choice type is exhaustive, how you can see. We don't need this default params to be fulfilled, and it's great, and it's really good for domain modeling. And a quick fun fact here, the second syntax without parameters with a sentence. And how you can see, it's slightly shorter, but those two are actually the same code base. And the first one would be kind of lame if you will write more in F#, and the second one will be the choice you will most likely make, because it's basically shorter. But it's the same thing. But is it any cipher? Because it's kinds of the same. On the left side, you have a C#, and on the right, you have a F# one. And on the left, you have an inheritance, and on the right, there is a choice type here. And once more, let's add the third one here, which will be a random invoice, the same way we've done with F#. And let's add it to explicitly to the contract, because in inheritance, you wouldn't need to do it, but if you have a choice type, you need to explicitly add this here. So another crap, obviously. All the things you saw already. So unpaid and paid for the strongly type. So how you can see here, after adding this choice, the compiler is not very happy about this. It says that the incomplete pattern matches on this expression, which means that we have to do something with this to make the compiler once again happy. And it's pretty simple. We have to add the third one here and say the hell yeah, or whatever else. And it's awesome, and it's very awesome, because we have a predictable code base with compile time checks. And that's what we need. And let me ask a crazy question one right now. And is it possible to have a tagged union in C#? And who would guess that there will be an issue already in C# language on the GitHub, created more than 5 years ago. And luckily, the C# language design meeting from August, you can read from this spot that they are starting to prototype it, actually. And at this point, I've started to wondering, maybe we can fake it until they make it. And from the message, the switch expression does not handle all possible inputs, that it's not exhaustive here. Let's emphasize here this part for a second. Can we somehow enhance the exhaustiveness check of the C# language for switch expression and somehow maybe steal it from our neighbors? And maybe an extreme approach, or I would call it a not production approach, would be to use this project, let's say. So the closed type hierarchy diagnostic suppressor. And as this project enhance the exhaustiveness check of C# compiled to switch expressions, in this example, you can see pretty much the same thing we've done already, which is the inheritance, but it's inside this time. So we have a nested classes, but so we have a root and different leaves that inherit from the root. And they have a method here called get, and it has a root as a parameter, and they do the switch here. But how you can see, this switch doesn't have a default case, which is crazy. So you can get this from the nugget, and just like in most cases, you just add it to the project file, and the funny part just starts, because there is no attribute and no configuration needed. It will just do the right thing. And the right thing is kind of hilarious here, but I love it. And it removes the not from the exhaustiveness check, but the problem is that it could be still dangerous to use it. It's not very production-ready solution, so it's most likely that you won't add it to your code bases, or maybe you work on some side projects, so maybe that's fine then. But can we find a production one, or at least something that will be more community driven or community like. There's something that community already use. And for the last time, let's add this: an unpaid invoice, a paid one, both without the inheritance here. And let's do the invoice the same way we've done with the F#. So we create a choice type, which is noted by the one-off because it's a one-off, and with the unpaid and a paid one, and those are generics as generic arguments here, and add some magic. As there is some caveat, obviously, as always. So call it the way you want, but we have a union here, and it's a matching time right now. It's a big moment. So on invoice, we use a matching function, which is literally a switch, the same thing we've done previously. So we do the pay now and already paid. And if you would like to add the third one here, so you add the random invoice, we will get a compile time check here saying that the method has 3 parameters but was invoked with 2. So to fix it, similarly to F#, we just add the last one because we have a compile time check here. So to sum up, if you use NRT, you should make sure that you enforce it at the compile as a compile time check. Otherwise, you're just a liar. And obviously, we need to ensure that the state is valid. I'm recalling here the Json deserialize example with a person. So you need some tooling because the C# language does not provide us, so we need something else if we want to have the same behavior as we have, for instance, in the Kotlin and Jackson, as you saw, and because we don't want to be like this guy. And last one, it's important to improve our predictability in our code by introducing more types to feel more of like this dude. So thank you very much, and happy to answer your all questions.
Awesome. Excellent timing. Thank you. So we have a time for questions. If you have any about all these topics, we are more than happy to answer. I mean, Rafa will be more happy than to answer. We have one, very general one, but maybe you can refer to it. Like, could you talk about the use of null? And you have covered that, like null with the exclamation mark.
Yes, it is a null forgiving operator, as I told you previously. And as I said, it's a pure way to lie. So, but there are cases where we use it sometimes. Imagine, like, for instance, you the test case, and you don't want to fill very nested object. And this is the one example where I would recommend sometimes use it, because let's say you just want to test one field in this particular test, and what's the point of filling the full object? Sometimes it might be redundant or will take a lot of space in your test case. So maybe this is a good one, but still think twice before using it.
Yeah, just like forcing that you know better.
Yeah.
And you want to lie just because you know, overcoming the safety that this feature tries to introduce. There's not a question, but overall comment, like null is a $1 billion genius, not a mistake. Obviously, I'm not sure what is in the end, what this person is trying to say here. Because null obviously overcomes the problem that otherwise we would be accessing something like dangling pointer or any other random access after freeing the reference or something. So instead of doing that, you are just being killed by null, accessing null. So you know that you do something wrong instead of just accessing some random parts of memory. So in these terms, it's better than not having null, but as you haven't shown, they are languages that are just not having null, right? Because we can express it by this option, maybe whatever we call it type, that expressed it better simply. So
Nothing to add more, really. I believe the path of new languages is to have tooling to avoid it. I believe that Flutter recently introduced the feature for nullability, and they force it very hard. And in C Sharp, we can't really have a hard changes. So like from the net 7, everything gonna be non-nullable, because we have to remember that .NET and Microsoft wants us to update to the latest versions of .NET, so they cannot make huge, very radical changes, because then we will not go to the latest version, and it's against of their policy, I believe.
Yeah, we will need to live with null till the end of times, at least in C Sharp. You can always change the language, like
yeah, that
for
would be
example.
actually cool to have like Java has Kotlin. It would be maybe funny to have some superset for C Sharp, maybe.
Yeah, that's true. That's true. Something that will just allows to remove the backward compatibility, right?
Yep.
Okay, do we have any more questions? Because if not, we will be slowly landing this talk and have a break before the next one. So there are the very last 10 seconds. From my side, thank you very much also for giving this awesome talk, and I hope it was also mind-opening and mind-blowing for some to see that in the end we have some edge cases and caveats in this nice and friendly language like C# still. Okay, no questions. So thank you very much. Thank you for being with us, and see you somewhere in better, not online times. Thank you.
Thank you for having me.
Thank you.